Hello everyone and welcome to AP Calculus AB lessons with Mr. Sand. Today's lesson is going to be on limits, more specifically double-sided limits. Before we begin, please go back and review your pre-calc topics as it is crucial to your understanding of the AP Calculus topics. So what is a limit anyways? A limit is a value that a function approaches as the values of its variables approach a specific number. Let's say you have a function x squared and you're trying to find the limit as x approaches 2. When the variable x approaches 2 in that function, the value of that function approaches 4. It gets closer and closer and closer to 4, meaning that the limit of x squared as x approaches 2 is 4. What are some ways that you can find a limit? One of the ways is known as direct substitution. This is a relatively easy method to find the limit. So what you would do when finding the limit using direct substitution is you plug in the value that the function is approaching into the function. This works if the function is a polynomial function or a rational function, and a is the domain of f. In this case, a is the value that the function is approaching to. If the value that the function is approaching to is not in the domain of the function, then direct substitution cannot be used. Let's look at an example. So you have the function x squared plus 3x plus 5, and you're told to find the limit as x approaches 12. You first look, is the x in the domain, is the value that the function is approaching to in the domain? And it is. Then what would you do right after that? So in that case, since it is in the domain, you'll substitute 12 into the equation, then you'll evaluate it, which will give you 185 at the end. This means that the limit as x approaches 12 of the function x squared plus 3x plus 5 is 185. Let's look at this function. If you look at the function, you'll notice that 6 is not in the domain of this function because it will give you an undefined number. So, in this case, this particular limit is classified as an indeterminate form. So, there's 3 ways that you can approach the limits with an indeterminate form. You can approach it algebraically, numerically, using a table, and graphically. You will need a graphing calculator for numerical method and the graphical method. Please prepare those calculators. It will be one of the few moments you'll be able to use the calculator in AP Calculus. So this is how you're going to solve limits algebraically when it's the limit is in its indeterminate form. This method calls you to algebraically manipulate the function in order for you to evaluate it. So let's look at it. X of 3, x minus 3 over x squared minus 9. So this is a rational function, and you're trying to find the limit as x approaches 3. X equals 3 is not in the domain of the function yet because it gives you an indeterminate undefined value, which makes it an indeterminate form. Then what would you do? So first, you expand all of the terms in the function. In this case, the top is already fully expanded. The bottom, x squared minus 9, can be expanded into x plus 3 and x minus 3. After you do that, you cross out the like terms, which will give you 1 over x plus 3. And you'll substitute 3 into the equation because you algebraically manipulated it. You'll evaluate it, which it gives you 1/6 as your answer. If you look at it right over here, I have the limit as x approaches 3 of x minus 3 over x squared minus 9 listed all throughout, right? Some of the teachers does not require this, but some people will require this. So if your teacher does, don't forget to do this step, as they might take points off on your test. Another method is the way to solve it numerically. So as you guys probably know, you can plug this into the graphing calculator and you can use the table function. This method will require you to use the table function. As we talked before, this this particular limit is in its indeterminate form. So after you plug the values into the table, you see 3 is undefined, but you look at the values as the function approaches 3. If you do, you'll notice that it slowly but steadily approaches 0.01666667 or 1/6. So using this method, you can guess that the answer is 1/6. So from these numbers, you can come into the conclusion that the value is approaching this specific number, and you can relate this to 1/6. Go ahead, put 1/6. You'll be right. However, if you can't do that and just want to feel safe, because you're using a graphing calculator, your teachers and College Board both won't expect you to put an exact answer. In that case, just round the decimal into 3 decimal places. So 1/6 will be an answer, or you can put in 0.167. That will also be correct. How to solve limits graphically. This also involves a graphing calculator, and you will actually graph it this time. You know that this function is in its indeterminate form, so you graph it into the function. I use Desmos for making this, but when you use your graphing calculator, everybody knows that there is a trace function, right? So solving it graphically is probably one of the least efficient ways to do it, but you'll trace the graph and find the value near the place that the function is approaching to. You look at the series of values as it approaches that position, and you derive the answer. In this case, it's at 0.166 at 3.02, and the graph is increasing this way. So it was safe to think that the decimal in this case will be 0.1666667 as it approaches 3. So I guess that the value of the function is going to be 1/6. But if you can't get to the answer, then it's a-okay for you to put 0.166 or 0.167. They will still count it correct. So even with those methods, there are still some limits that fails to exist. One of the ways is when the function is approaching different y values from the right and from the left at a specific x value, as it's seen right over here. In this function, 0, from the left, the function approaches -4. From the right, the function approaches to -2. In this case, a double-sided limit cannot be found because the function approaches a different value from the left and the right. The next case will be when the function decreases or increases without bound as x approaches a, meaning there's a vertical asymptote. When there's a vertical asymptote, one person cannot find a double-sided limit. Well, some might argue, well, can't you just say that it's approaching infinity or negative infinity? Well, double-sided limit can only be integers. No infinity signs are allowed in double-sided limits. So this particular case will be invalid during a double-sided limit. But when we later get into a single-sided limit or infinite limit, you'll be able to find the limit of those cases. Next one is oscillation. Basically, oscillation means that the graph of the function moves up and down in the same interval over and over again in that particular x value, as is seen right over here. It goes up, down, up, down, up, down, up, down, up, down. This case is called oscillation, and you will not be able to find the limit of this function. So that concludes your first lesson in AP Calculus. AP, thank you for listening to me, and hope you guys understood this topic. Thank you.